Okay, again, we want to graph a cosecant function here, which is very similar to a secant function in this way. In that, for y equals negative 1/3 cosecant of pi over 2x, we would handle this by treating this as a reciprocal of our sine function. I don't know if you recall, we said that if we had a sine function, its reciprocal would be cosecant. So what we can do is we can use the function y equals negative 1/3 of the sine of pi over 2x. That's a 2, trust me. Pi over 2x in order to help us get the locations of asymptotes and the shape of our graph, so to guide our sketch. All right, so let's look at what happens with this function. Of course, we know that one thing that we're always interested in is the amplitude and the range. So our amplitude is equal to 1/3. Our domain, sorry, our period, we need the period here, the period of this function is going to be 2 pi over b. So 2 pi divided by pi over 2. When we take the reciprocal and multiply, 2 pi times 2 over pi, what gives us 4? So our key points within one period are at 1/4 of that period apart. So 1/4 of 4, of course, is 1 apart. Interesting, interesting. Okay. So if we're looking to set up our graph right now, let's see, the x values, the key points for x will go 0. There's no phase shift here. 1, 2, 3, and 4. So the y values, the way this is going to work right here, of course, for sine, because we have a negative value right here, the y values go 0, negative 1/3, right? It would normally be 1. We take negative 1/3 times. That's a negative 1/3. 0, 1/3, and back to 0. All right. So now, okay, let me just go ahead and graph that. Let's put our main points on the x-axis right here. I'll mark off my x-axis by the lengths of each of those key points. So 1, 2, 3, 4, etc. Sort of conveniently working out for us in terms of those values. Don't worry about if you don't see pi, right? We divided that out as part of our calculation. Here's negative 1. And of course, the range was negative 1/3 to positive 1/3 for the sine function. You know what? I'm going to make 1 right here so that each of these lines are 1/3 apart. How's that? Here's 2. Here's negative 2. All right, that makes life easy. All right, so if I'm graphing my sine function, how's it going to work? Well, it goes like this. It goes 0, goes down to negative 1/3 at 1, goes back to 0, goes up to positive 1/3 at 3, goes back down to 0, and then just repeats this pattern over and over again here. And again, it's not really necessary for me to actually dash in this entire graph. I might just lightly put it right here just so I know what's going on. But already I know what's going to happen, because anywhere where my graph was equal to 0, I'm going to get a cosecant that has an undefined value. So if I say y equals cosecant 1/3, sorry, negative 1/3 cosecant of pi over 2x, we're going to get our y values here out undefined, right? That's a vertical asymptote. We're going to get negative 1/3 at this point. We're going to get undefined at 2. We're going to get at 3 positive 1/3. And then at 0, we're going to get a 4. We're going to get undefined again, and that's the way it's going to go, right? We're going to get a vertical asymptote at 0, a vertical asymptote at x equals 2. We're going to get a vertical asymptote at x equals 4. Let's see if my hand can stay steady here, going down the screen. There it is. 6. One would suspect it's going to go through 8, -2, and so on. So, okay, what happens here? Well, our graph is going to pass through -1, -1/3, but it'll go towards -infinity as it approaches either of these asymptotes at 0 and 2. It's going to come down from positive infinity, pass through 3, 1/3, then go up towards positive infinity. We're going to have another branch that goes from -infinity, passes through 5, -1/3, goes back down towards -1 infinity, comes from positive infinity, goes down towards 7. Now it would actually loop back up. I'm not going to show the whole thing. We can also show another branch back here if we cared to. This is our function, y equals -1/3 cosecant of pi over 2x. And if we're just asked to graph, that's fine. But of course, graphing's never enough for me. I actually have to show things like asymptotes. Where are the asymptotes from negative to positive infinity? Where are those going to be located? Well, you've already noted that our asymptotes are occurring at values like 2n. Now, how are we getting that? Well, a good way of thinking about it, again, is to remember that whatever our cosecant function is, normally we would be getting asymptotes at wherever we get n times pi units, right? But one way of calculating it is to take the argument pi over 2x and set that equal to n pi. And since n pi is sort of the default for our sine, our cosecant function, then we do that. Now, if we solve for x, we multiply both sides by 2 over pi, and what happens? Well, sure enough, pi divides out, and we get our asymptotes at x equals 2n. So if we're looking for our domain is going to be all about the set of values x such that x is not equal to even values of x, 2n values of x. And our range is going to go from -infinity to -1/3, and it will include -1/3, union with the set from 1/3 to positive infinity. Now, one quick word right here about the range, and I've gone through it now twice with this cosecant function, with our secant function, and with our basic cosecant, secant functions. In sine and cosine, there's always an amplitude. What could we say about cosecant? Well, the answer is because we have no maximum or minimum value, we're going to go say there's no amplitude at all, right? Now, we use the limits of our amplitude from sine and cosine to help us guide where these branches go, but for all of them, we would say no amplitude exists because it is not the case that we need to have an amplitude for every single function in the universe here. So I'm going to just say, well, all right, that's the case, right? And every single one of these functions that we look at, there will be no amplitude. I'll move on to my next one here. There's no amplitude here. And likewise, no amplitude here either, right? So just be very careful to note that whenever we're dealing with secant, cosecant functions, we don't ask about amplitude because, well, it's not really even necessary here. Okay, more to come.